Thanks, Bernhard, for the introduction, and welcome also from my side. And I'm happy to show you my session or my presentation today, even if it's not really technical. We are staying completely in the native client of Qlik. So today we won't do any hacking, coding, maybe hacking, but no coding, and everything what I will show should work at the end in one chart, and that's the map chart. And hopefully you will find it interesting. So let's be surprised what you see in the next minutes or even hours. I don't know how the rules are. If there are any questions, I don't know how many people we are, but feel free. Maybe I will stop at specific points in my presentation where you can ask questions, so we don't need to collect them until the end if something needs to be answered immediately. Okay, so how does my presentation look like, or how do I plan the agenda for this session? So first, of course, we are talking about the map chart, and in the beginning, we will do like a really quick overview. What are the capabilities of the map chart, and how does it work actually? So how do I need to provide coordinates that it can visualize some kind of data? What kind of shapes are supported? So we will do like the real basics in the chart. And then we will leave the standard geo approach, and my idea, what I developed actually in the last weeks, it's pretty fresh also for me, is and I extended the idea. So I had the idea already and started to work with it, but now I extended it a little bit also to use different kind of image types to receive vectorized images. So the idea is to not only have images, static images in dashboards, but to have images where you can click in, where you can make selections, where you can visualize KPIs on. You will see. Hopefully, you will understand the idea what is behind. And last but not least will be some kind of small workshop. So I have prepared 2 small exercises, and just to show you my idea how to reach the goal of vectorized imaging in Qlik Sense. Okay, so why do we need images? And I think you all know the criteria and think about as BI consultants. What do I need to reach that that at the end the customer is happy, that we reach their goals with that dashboard, and where are, from my view, these main criteria like data. You need to prepare the right data in your dashboard to transport the right methods. So you want that the business users or users of your dashboard get insights out of it and get the right message out of it. Of course, it's important to have it in the right performance, so it should actually work as expected. And last but not least, and sometimes it's maybe the most important criteria for a successful dashboard, it has to look good. So it has to be appealing. It has to create some kind of excitement. So that would be my goal, and that's the goal, I think, of my session today, to give you some ideas how to create excitement at your user base. And I've added a standard image here of a standard Qlik Sense dashboard, and I think you all know that Qlik Sense follows some standards, and it's not really easy if you use the native capabilities that are in our Qlik Sense client to really build something extraordinary. I would say most of the dashboards look at the end the same. So you have like the standard bars charts and pie charts and KPIs. And if you have seen like 5 standard objects, you have seen them all. So how to create excitement. And I always say, and this is the feedback I receive, the first excitement is if you have some kind of geo data, location data in your data, just put a map on the first page, and many users will say, wow, cool, hey, a map, and I can click on it, and it's responsive and interactive, and I can drag and drop in it, and I can change the layers, and hey, that's a cool feature. That's the beginning, and we will only touch it on the surface today. The next idea is, hey, why couldn't we add like additional images in ClickSense to make it even more appealing, so that the people say, hey, cool, I see my process data here, I see my production line in Qlik, and I see and it actually, it's not only looking maybe better, but it also gives you the data in a much easier readable way. So in this case, I've added like an image and put some KPIs on it, so you see the main KPIs on this process, not only in traditional KPIs that you see here on top. These are the global KPIs, but now on the level of the process at the right place on the image. So that's the idea. And at the end of the workshop, I would like to cover like how to bring in an image here, how to maybe add additional objects on it, and or how to make it clickable, that I can select directly in the image and don't need to go through the standard way of selecting that ClickSense provides. Okay, this was the short intro. So now you know, hopefully know what can you expect today, and let's go to the basic stuff. So what is GeoAnalytics? And I'm sure most of you know that or have used it. It's a mapping solution in ClickSense. So it's a multi-layer visualization that was acquired. So maybe those of you who are working longer with Qlik know that 3 or 4 years ago we have acquired a Swedish company that has offered a visualization extension, and the solution was actually already called GeoAnalytics, and it was an extension that was integrated in ClickSense, and in the release in the past releases we have integrated all these extensions in the standard client as a standard object that I think is really good. And so we made all the extensions actually not really necessary anymore for ClickSense. Of course, you can still use the extensions for QlikView, but for ClickSense, we have the native map chart, and at the end, I think it has already more features than the old extensions. But what is also included, and that's also an interesting part, is the analytics part. So in a visualization, just to give you an example, so in a visualization, you see, for example, a warehouse and the customers that receive deliveries from that warehouse. But and you see, for example, which customer is far away, which is nearer to the warehouse. But you can't really, you don't really know what is the real distance, how long does it take if I have a truck that drives from the warehouse to the customer. And this is what the GeoAnalytics gives you. So it's a service in the back end that, for example, can calculate routes for you. So you can extend, it gives you geodata back. So you can, for the GeoAnalytics service, extends your data model with geodata, and you can use that data to better understand your mapping data and to extend that data. So that's actually the idea. How does it look like? I have some examples in a second. So this first, how does our map object look like? What capabilities does it have? So you have a multi-layer map, or you have multi-layer visualizations. So you can add the standard points, lines, areas, but we also have density charts. We have a chart layer to get pie charts or bar charts on a map. Lines, this is what I've already mentioned. What we have also added are additional layers, for example, to change the background tile map service. So out of the box, we are using OpenStreetMap. But if you have, for example, a Google license and want to see Google tiles, this is also possible to change. And what I will use today after the overview is we can also add images here. So you can add custom images and draw shapes on it. So, and that's the idea of how to reach maybe the example you saw before. And yeah, but you will see that in the workshop. The geospatial operations that are offered through GeoAnalytics can be categorized in three areas. So the first area are geometric operations. So for example, just to give you an example, in a mapping solution, you see these areas. So these areas represent the catchment area of a shop. So for example, I have a shop and I can reach the dark red area within 5 minutes, then 10 minutes, and the light red in 15 minutes. And what I see in a mapping solution is that there is an intersection between red and blue. But so I can now estimate, okay, how big is the intersection? But this is what comes now through the geometric operations. I can calculate the intersection. For example, I get a number like 20% intersection, and with that 20%, I can then calculate how many people do I have some kind of cannibalization between their two shops. A second category, aggregations, are typically used as in every other chart. If you have a lot of data, if you have millions of points, it doesn't really make sense to display all these points on a higher zoom level. So you need to aggregate it to see something in your data. And we have like these two quite nice aggregation methods that give you a really nice view of your data. The first one is binning, that delivers hexagons or rectangles, so aggregate the points in a specific area, and then you can create these kind of heat maps on the aggregation layer, but still have access to the detailed data. So if you make some selections, you are again reducing the amount of data, and then you can jump down to maybe another layer to maybe a point layer to see the details in a specific area. And the second operations that are quite powerful are route operations, and they are calculating a simple route between 2 points with the parameters. What kind of vehicle are you using? Is it a car? Is it a truck? Or are you walking? Or is it are you even interested in bird distance? And you have the parameter closest or shortest or fastest or shortest route, and then the algorithm calculates the route for you. And it also includes travel areas. This is what you saw before. So we can calculate the area that is around a point. So it's typically not a circle, because it respects the streets and that are in that area. And we also have a closest algorithm that where you can put in 2 data sets, and it calculates the closest relation between that data sets. Okay, architecture, I will jump over this in a standard deployment, and I think that's in 90% of the use cases used to be the service that provides geodata and does the geoanalytics is hosted by Qlik. So this is running somewhere in the Qlik cloud, and it is part of every Qlik Sense deployment, and you can simply use that the data and the operations. We have some limitations because we can't allow that you process 100 million routes at one time. So you need to split your data just to that you not come over these limitations. But you have all the possibilities in the product, and you can use them. Good. This was like the first section to give you a basic overview. What is geoanalytics? Any questions so far? That's good. So this was maybe too general for the hardcore technicals. But I hope it's getting more challenging now. So let me jump to my next section. So what are the basics? And as mentioned, the geoanalytics supports different kind of layers, and it's important for the further work to understand how does the configuration work, how do I define the different shape types. So it's pretty easy to understand it because it's based on a standard. The standard behind that is GeoJSON. So if you understand how JSON works, it should be easy to also understand how the point works. So just to go through the different shape types, we have like a point that contains a longitude and a latitude point, and with that information we can put the point on the right place on a map. Second type is a line string. A line string contains of at least 2 points. So we have like a coordinate and a second coordinate and a third coordinate in my example, and this draws the line. Because we have like multiple points, you need to add a second square bracket to enclose the points. Third type are the polygons. And the difference to the line is, and I've marked it here green, is that a polygon always closes with the beginning point. So that means that we have like this point as first one, and the last one must be the same one. So we can close that area and give it a background color. What is also supported are polygons with several areas. So that means so for here we have like 2 polygons in one shape, and this is required, for example, to visualize US and Alaska. So you have 2 separated areas, and to really have this data in one object, we need to use that kind of multi-polygon or polygon with several areas in it. So this is the basic. For geoanalytics, we rely on a standard that is called VGS 8084, so World Geodetic Standard. But today we will work more with pixel. So of course you can switch on the map chart that you want to draw with pixels. Then you can use pixels. Okay, that's the basic. I just want to mention this because it's quite interesting. The challenge, if you want to draw something on a map, is how to get the data. So from where do you get the polygon information, for example, to draw a world map? And this is also hosted on our service. So our service for geodata has around about 7 million records with areas, places. So for example, cities, airports, and others. So if you have, for example, a city name in your data, you simply need to drag and drop your city name in the map chart. The map chart sends the name to our service. The service gives us back the latitude and longitude. In the case of a point for an area, you get back the polygon information as showed before. You get it back, and then the map chart can visualize that data. What is also important to know is that we have collected only open source data. So we have quite a good coverage in Europe. Yeah, you see it here green, for example, for zip code data. So that's a typical standard question. So I wanna visualize my data on zip code level. Do you have the data? And we have it, for example, for Germany and Switzerland in our region, but currently not for Austria. So that's why we are offering different possibilities how to integrate your own data. If you can't get the data directly from us, from Qlik, you can get external data. So there are services that sell, for example, geodata. Some customers have their GIS systems, for example, Esri, or installed, and Esri can generate data that we can integrate into Qlik. So I would say we support here the most common standards for data for external data to integrate it into Qlik Sense. Yeah, what is also included is a service from Qlik. So if you would like to go below the zip code level, and the standard here is on address level. So you have, for example, addresses of customers in your data, and you wanna have the geo coordinates to visualize it on a map. We have a service also for that here from Qlik. But of course, you can also use other services if you have already one in your company. I will jump over these slides and overview what kind of operations are really included. That's a more detailed view. And as said, we have that 3 categories: geometric, aggregation, and routing. But we are also, of course, offering also lookup operations that you can make the lookup not only in the map chart, but also in the data model. That's why we have that category also here. And what is also included in Qlik Sense is, or in the native Qlik Sense, so in our engine, we have a set of geometric operations just today as an overview, that you can decide if the function is already in the native engine. It's of course much faster than sending the data out to a GeoAnalytics service that is hosted in the cloud. So for example, if you want to aggregate geometries, so that means that you have several polygons and want to build out of it one big polygon, I would recommend to use that feature from the engine and not sending all the data out to the GeoAnalytics service, because typically all processes that run on the engine are much faster. Good, and I'm sure you have heard that Qlik is on the way to become a SaaS and a cloud company, and currently on our Windows installation, all these operations and aggregation and routing are calculated or transferred by a connector. So you have a GeoAnalytics connector in your in the data manager, or typically you are using for this the data editor. So you, in the script, you have a specific connector for GeoAnalytics. On our SaaS environment, we have some kind of different architecture. We have developed a server-side extension, so it's already there and you can use it. There is a documentation, and I think we have all possibilities that can be done on Windows can also be done on SaaS through the server-side extension. Good. So what is important now to remember for the next session? I would say the most important thing is to understand what kind of shape types do we have, how do they work, and yeah, that's the main thing, because I would like to show you how you can reach these kind of visualizations, and I have built some of them. Some of them were built by my colleagues. I don't know if I have already introduced myself. So I'm working for Qlik, and I'm really looking for many to see a lot of examples that were created by my colleagues. So we have our visualization product manager is coming from that company that was acquired by Qlik, and so it was IDEVIO. They built the geo analytics extension, and he's now working for Qlik as visualization product manager, and he builds a lot of examples based on the geo chart, what is possible, and I will show you in a second some of these examples, and just to give you a first impression what is possible with the geo chart.
Michael, we just had a brief question in the chat regarding if you can shift the calculation, for example, for routing to on-prem servers. Maybe Patrick can specify, because, or is that enough for you?
Hopefully. So I didn't go into many details on the architecture, and if you are using the out-of-the-box capabilities in Qlik Sense, we are doing the calculation not on your server but outside on our server. We have an enterprise server that can be installed in the network of the customer and does all the calculation for you. So if you have some security or compliance requirements that make it necessary to have everything on-prem, Qlik is offering a solution for that.
Is there
I
a
hope
name?
that answers.
Is there a product, or what is it?
Yeah, there is a product called Geo Analytics Enterprise Server.
Okay.
Yeah, thank you. My question was more on the usage part, because you mentioned that there are limits on the calling the API of the Qlik cloud servers. And my question was regarding how can we shift these calculations to on-prem and use our hardware to not exceed these rates, maybe at some point.
So if you plan to heavily use it, I would always recommend to use the enterprise server. But at the end, it's a lot of data behind that. So as far I know, the routes are calculated based on the images that we have from OpenStreetMap, and the data package behind the enterprise server is around about 16 or 20 already, I think 20 gigabytes big. So we have the database and all the images from OpenStreetMap. So it's a lot of data that comes through the enterprise server, and this GeoAnalytics enterprise server can do that without the limitations that you see on one of my slides before.
Okay, thank you.
So what I see is that even here at Qlik, if I talk to our consultants, that the knowledge in geoanalytics is not really broad. So it would be interesting here to hear who has already used that capabilities, and if it really helped you in your project. So to be open, I haven't seen it too often, and I'm always curious to hear some success stories. So is there anyone who has already worked with the GeoAnalytics connector, and what was the feedback in your project for that? No, this is what I expected, that there are not too many people. So we need.
we use the routing operations from Click Analytics for policy and victim calculations to see which is the nearest policy to help a victim.
Okay, cool.
So a very specific proposal.
But that's always, I think there are a lot of cool use cases, and we need to spread the knowledge, still spread the knowledge even after this solution is already 4 years, I think, in the Click portfolio. Many people think it's still very technical, but to be honest, it's not really. So everything is done through the connector. You only need to put the right parameters in the connector. That's maybe sometimes a challenge. So feel free to use it and to test it. I think there are in every project or in many projects we have geodata that can be extended with additional information, and so you use it. Try it out. It's pretty straightforward to use it. And Patrick, our product manager, has written a lot of articles in the community and best practices, and that support you to reach your goals in the project. Good.
And we have one question from Marcus. He asks about the additional costs for the enterprise server, for the GeoAnalytics enterprise server.
Okay, so I'm not a sales guy. What I know, it is included in the ClickSense. So if you have a ClickSense license with professional and analyzer, the base version of GeoAnalytics is included, and my assumption is that this is already enough for 90% of the projects.
Yeah, but is the base version enough to shift the calculations on premise, or
no? No, but it's enough to do the first calculations. I don't see I don't see that it is required to have everything on prem. Actually, what you're sending out in many cases are for example, zip codes. That's not really confidential data. If you maybe send out addresses, then we can maybe discuss if it's already sensitive data, and the data needs to be, if you have like regulations that say all the data needs to stay on-prem, then maybe you have to consider to look into the enterprise server. But as you know, there is a shift to SaaS, to the cloud, and the customers are getting more open to use cloud services. So of course, if you are using ClickSense SaaS in your project, it doesn't make sense to use the enterprise server. Maybe it makes sense, but not. But there are only a few cases to have the geo calculations on prem, and then to use them on ClickSense SaaS. So or Click SaaS. So the trend is going to the cloud, and we see not too many requests for the enterprise server anymore, because we see the shift already that many customers are interested to use our cloud.
can it be a use case to lower traffic in order to transfer it to on-prem? Or is that not?
I would say that all these calculations are typically done as mentioned in the script. So they are done by batch processing, and it is not required to do all the calculations every time from scratch again. So with Click and GeoAnalytics, you are allowed to store the routes that you have, for example, calculated in a QBD and reuse it. So you only need to prepare new data or to send new data to the service to calculate it. So with that approach, you can already limit the amount of data that is transferred to our service.
When you say you transfer the data, have you ever researched the effect with regards to GDPR? I mean, if I'm a bigger company that has to make sure that GDPR is applied, and then I hear something is being sent out to other servers, I would be suspicious, let's say.
Yeah, we have heard that question several times, and so there are some best practices how to send data out. You shouldn't include names. You shouldn't include IDs or birth dates or something like that. So the developer of the application can decide what kind of ID is used with the geo information. Of course, you need to send out the zip code, for example, and you can generate like anonymous IDs to bring it back in your data model.
Mm-hmm.
So you shouldn't use names or something like that. So we have best practices to fulfill the GDPR requirements.
Okay.
And on our side, we are GDPR ready. So we are not collecting any data. And as you know, our whole SaaS environment is GDPR ready and has a certificate for that.
Okay.
Good. Then let's look into that example. So I have collected some of these here to show you what is possible with the map chart, and I have them here on my SaaS tenant. So this is in German. Let me, but I don't think it's a big issue. We can go through it. Or let me maybe for my presentation later change to Firefox. Of course, I need to authenticate. Okay, now we have ClickSense here in English, and I have created a space, and I have added some of the geo-analytics examples here. And okay, I'm missing one, but that doesn't matter. I will start with this one. You have already seen it in the in my screenshot, and I really like that example because okay, that's not too relevant because we have here added a human body to this dashboard, and so we are using polygons to also stay a little bit on the technical level, and now we can visualize directly on a body where most of the scans in our data happen. So, for example, we have a lot of scans on the right eye, and here on the shoulder. And what makes it also cool is that it is interactive. So you don't need to go through a filter or here a nice bar chart to find the right part of the body. You can simply click on the shoulder and see, okay, how many scans did we make there? What were the results here? So fully interactive. You see, it simply generates a standard filter by clicking on it. So I would say, and many people who see that say, okay, that's already pretty cool to have like these kind of images in ClickSense that are fully interactive. And of course, it works in the other direction as well. So if I click on an organ or on a hand, for example, I will see the hand. Another example that I've developed with a car manufacturer is this car manufacturer was interested to visualize their quality data. And so far they had their quality information like based on the part of the car. So for example, they could visualize, okay, we have errors on the window. But what they didn't have is on which position these error occurs. So so we can jump down. So for example, we see here the door, and or here, and you see directly in a visualization in which place of this part of the car you have a hotspot of errors. And that's like a really cool and I would say exciting feature for them, and they are using it already in production. So that's a cool success story for the approach, adding images here, and on top of the image we have the possibility, and I've played around with different kind of layers. So here in this example, I have used the polygons to create some kind of raster. But of course, we can also use points, or even the heat map layer gives us a nice view of the hotspots. And again, it's fully interactive. If I click here, I see it on the other charts. It directly zooms in. So it's really a cool usability. Of course, you can decide. Do you want to zoom in? Do you want to keep the view that you had before? So you have the advantage of our map chart is that you have a lot of settings to really adapt to your project requirements. Next example, and this is something.
Maybe just a question to get an idea on the workload. How much work was it to design the polygons in order to make an overlay?
Yeah, you will see it in a so this is something I will show you in the workshop. I've some further ideas, and you will see it's. I will show you my latest example that I've built, and I can show you some tech, also the expressions that were required to generate that, and you will see it's some work behind that. So it's not coming out of the box. Just to cover some examples that were created by Patrick, and he published this application every year, or even two. He creates even 2 applications every year with tips and tricks for visualizations, and sometimes also an application for tips and tricks around geodata. And so, for example, Patrick used in this example, he created a radial bar chart, and and he has used, and you will see it. He has used the map chart to generate that visualization. So if I click on it, I can see what kind of layers did he use, and yeah, it's not too complicated. So he has like 2 line layers and 1 point layer. Of course, he heavily used like geometric functions to reach all the circle part, but now you see what is possible with that chart, and then it's really impressive to see that. And in this application, there are several other examples. For example, here a fish eye chart, or that's also a cool one, a radial. I even don't know the name of these charts. A radial bar chart. And this is also GeoAnalytics. You see the different layers. So he has a line layer included, an area layer, another area layer, and a background layer. And you can really generate these kind of super cool charts with it. And you can also, of course, use variables to set some configurations here and change the ratio between the objects. And yeah, that really looks cool. What else is interesting? Pie chart. So that's also a standard question. Of course, it's possible to generate standard visualizations that we already have in the product. sometimes we receive the request that we would like to have a measure in the center of a pie chart, and yeah, you can generate this also with GeoAnalytics. So just to give you a technical view on it, so Patrick used 5 layers to reach that. It's not that easy, but yeah, it works. At the end, you have like points, lines, and polygons, and you can draw everything with it. And that's pretty cool. I will jump out of this application and will show you my geo example where I spent most of my time with it. So I've generated, go back to that space, and I just explain you the background. So I'm working for companies that use ClickSense in technical areas. So for example, for IoT use cases, and they realized that ClickSense is a cool tool, and we have like super cool approaches how we can handle a lot of data. For example, and in my requirement, we had we have used a scatter plot. So, and as you know, ClickSense starts to reduce the data, to compress the data if you reach. Okay, if you if you are maybe over, there is a hard limit at the moment. So if you are above 1,000 points, ClickSense starts to compress your data. But you you get a really nice overview of your data in this compressed scatter plot, and you still have the possibility to by zooming in to see further details if you want to. So if I zoom in. At one point, it's all the time. It's recalculated for the visible area, and if I come down to less than 1,000 points, I see again points. So this is quite a nice feature to get an overview. But I have already received several times the request, hey, I want to have a scatter plot where I see more than 1,000 points, and my idea was to use a GeoChart for that, because a scatter plot, it's for me, it's a point chart, and I will hide this one, and I can simply press on scatter plot, and now I can generate not 1,000 points, but it's possible to visualize up to 50,000 points, so 50 times more in a GeoChart. And it is interesting, maybe not for this area, but my customer was really interested to see that outliers and wanted to mark that outliers with another color, and therefore we have that nice possibility with the GeoChart to build even standard charts with it. And it's of course it's not easy. It's quite easy to get the points. The challenge here is to calculate the right axis and all the stuff, and then it generates some effort, of course. What I also did is I re-implemented our scatter so that I can influence it. For example, now I'm able to set a compression rate. And what is also cool, it's not limited to a view, so I can still, for example, if I'm interested in a specific area, I can select it, or I can do the selections here with a tree map and select a specific area, and it recalculates and gives me the data that is selected. So it generates my axis, it recalculates the values and all the stuff. This is possible just with the map chart. So actually, I'm calculating everything by myself. So I've used it as a charting tool. And what's cool is that you can define rules outside for layers, so I can switch on layers, switch off layers. So in my example, my customer wanted to have statistical lines in the scatter plot, and it was possible to do that, to reach that with the GeoChart. And here I can show you maybe some further details. Let me just put that away. So how complicated is it? You see, I have some more layers. So every text that you see on that chart is a specific layer. So for example, I have a layer for the x-axis, I have a layer for the y-axis, I have a layer for the grid, I have a layer, if I switch that off, I have a layer for the compression layer, and I have a layer for the scatter chart. So a lot of different layers. And just to give you a first impression how such a expression look like, and let's see what is behind there. So now what, and this is what I also will be part of in my example later. You see how I calculate the grid, and it's based on so I'm actually not using data that is coming from the data model. So I'm using here a loop, value loop function that generates this grid. So this is the light gray one in the background. We just also hide this one. And what I need to calculate are these 4 points. So you need all the edges from these rectangles, and that's why you see how in all these expressions you see how I calculate my polygons. And you see, like, this is my x coordinate, this is the y coordinate, and because you can make selections, and it's getting more complicated, and I'm using a lot of different variables to make it possible. You see it down there. That's one of the easier ones. I can show you the heat map function. I think it's also looking pretty easy because I excluded everything in variables, but you see down there how it's somehow complicated to reach it, but it's possible. You only need to calculate the coordinates. That's the challenge here. The real data, just to show you, for example, the scatter, that's pretty simple. And that's super simple because you have, like, you're getting a x value, that's your measure, your first measure, and you have your y value, that's your second measure. I have to use some ratio functions, but actually to get a scatter, that's easy, but to generate the axis, the right grids, that's somehow a little bit challenging. So, and the same, I think, in the examples of Patrick, you can download them from the community, and if you're interested, you can then dive into how he has done it. And if you want, of course, I can. This is no confidential data. I can also share this app if you wanna build really highly complicated charts. So what is the idea? Actually, I'm doing multi-layer charts with the GeoMap, and I have all the freedom here to add additional layers as I would like to do that. Just to mention it here, my idea was here to visualize high density charts, so charts with where we see a lot of details. And my next step here was, so I found it pretty cool at the beginning. Okay, what is possible with the GeoChart, but I saw the challenges also. It's really hard to find someone who can do that. And that's why I have also built extensions to cover that high density use cases, especially in IoT use cases. And in these extensions, I have used a third-party library that was able to render not only 1,000 points, but up to 500,000 points. And we also have some challenges with specific time series and line charts, and so I've created two extensions that are built especially for high density charts. Just to mention it here. So this was the result of all my of all my things that I've built with the map chart. Okay, and last example for today is, and this is what I found out after the conversation with Bernhard. I thought, hey, I need to find something new. I need to start for, oh, okay, that's not good. I didn't publish the sheet. I need to have a new story for that workshop, and I found out a pretty nice way to read SVGs. And I have found some cool looking SVGs with Google and brought them into our native chart. And just to show you, it doesn't have a real project background, but it should simply show, hey, what is possible, what can we visualize in Qlik Sense with the map chart. So you have the freedom, of course, to do everything. And with the approach with SVG, from my point of view, we are getting more flexible to integrate in our standard map chart more and more different visualizations. So for example, I found this nice SVG with this astronaut, and I can now simply, for example, select the arm and jump into that details. And I really like to work with it, and it has all capabilities that you know from the map chart. You can select, you can define the color. So if you want, let me just if you want to change the color here, you can use the standard color function, and so on. So it's the map chart. Just to give you an example here, I want to have the color by measure, and then so I have a random function, so I can give my astronaut a more fancy color than the gray. Okay, these were my examples. I have put most of them on the GitHub page. You can download them, and if you're interested, and play around with them and see how they work.
Well, thank you for the presentation. Very interesting. I like it a lot. I wish I had more use cases where I can practice a little more. But anyways, we have one or two more questions. Yeah, one is, how do you create a custom layer for maps?
Mm-hmm. Yeah, so what I have planned after the demo is a quick workshop. And I have prepared 2 small use cases, and I will actually show how it works.
Great.
So I think we need maybe additional 20 minutes to be optimistic. Maybe even, I don't know how good my mood is today on Monday. Maybe even a little bit more to create that examples. I will show them quickly what I've prepared today. So my first example is I wanted to show you one idea or one approach how you can digitalize an image. And here I found a map of Vienna, and now it's possible like to click on the sites and select them and use it as a map chart. So you see, I have integrated the image, and I have created a polygon layer on top of it. So you can then use it interactively, and also add maybe points on it, add text on it, measures on it. So it's a really nice approach how to make images interactive. And my second example, it's a basic chart. So my idea was to here especially for our workshop, to find a nice way in this case to display survey data. Of course, we can in a category from 1 to 10, and I've used the map chart to visualize the results. And this is I can quickly show you. So I have like my text, my question. I can add my text, my question here, and use the map chart to create these quadrats and to visualize the data. This is a super simple example for the beginners. Okay, any questions? Otherwise, I would just jump into my one slide explanation how this works and what is my idea, and then
Okay, maybe just one
Mhm.
question we had, and it's like, do you have good guess on the approx effort of hacking the map chart for these special visualizations versus creating an extension slash mashup using the engine capabilities and external JavaScript Vislib library or Vis library?
That's a good question, and I have created, and we can do that maybe before. So I have like thought about the technical limitation. So what can be reached with the map chart compared to maybe an SVG extension. And but I haven't thought about the effort. I think in many cases it creates more effort to get an extension in the environment of a customer, and because many customers are blocking us and say, okay, no, I don't want to have too many extensions, and please find a way how to implement this use case with the standard capabilities. But yeah, I hope that after the workshop you get an expression how complicated it is to get that data into Qlik. I don't think it's too complicated, but of course, if you want to have it pixel perfect, and then of course it can generate more effort. But
Okay.
this is what I wanted to show on my last slide. But we can talk about limitations now. So a vectorized image is never that good as an SVG. So in SVG, you have not only the polygons, you have an object type called paths, and with paths you can create super detailed shapes. And actually, I don't think this is really possible with polygons. And so you see the difference. So typically, a vectorized polygon looks like that, and a SVG has much more details. And then I found a nice article why it is so. The SVG paths support like super complicated mathematical functions and curves, and a polygon is just an array of points. And you see, of course, with many points, you can reach almost the same, but I don't think it makes sense to like if you have like these complex shapes and maybe a super complex image to generate that with polygons. That's why I would say if you have like an easy chart and it's and the customer is happy with like a schematic representation of the image, then the map chart is enough. But if you have like a super complex requirement, maybe you should think about using extension or building extensions by yourself. I don't want to go too detail. Let's jump into the workshop, and I think you can have a look later into this presentation. I also published it, or I will publish it into my GitHub folder. Okay, so first let's go back to my Qlik Sense. So what is the first task? So and let's maybe go here where I'm describing what is required to do that. So the first and the biggest challenge is, of course, we need the right image. And in the best case, the customer can send us an image. Sometimes it's required to use Google and find the right image, as I did it. Or even if you want to visualize a process, you can generate an image with PowerPoint, for example, and then bring it to an SVG tool. And in my case, I'm using Inkscape, and with Inkscape, we have a pretty nice possibility to draw polygons or SVG elements on top of an image, and this data can then be converted into polygons. So Inkscape generally generates SVG paths. These paths can be transformed to polygons by a third tool, and then I have the possibility to load these polygons into ClickSense and visualize it on a map chart. Sounds complicated. It is not too complicated. So let's. I will show you what is my idea here. So I have prepared this Vienna image, and I have to find it. Let's do it in that way. So this is a standard PNG that I've downloaded from the web page, and I can open Inkscape. That's an freeware tool for SVG. So if you're using or if you're looking at Google for an SVG paint tool, then you will find, I think, the top tool is Inkscape. And here in Inkscape, you can open the image. And okay, let me just copy the URL. So, and I can add the image here to Inkscape. And now I can use a feature here, this painter feature, and take a color and just simply click on my objects that I want to mark. And you see it here on the right. What Inkscape creates for us is a path, a representation of my shape here. And and this is what I did. I pressed on all the buildings and with that and stored it as SVG. And so I had a first SVG based on that image. That was my first step. Then I will do it a little bit quicker. Then I have received this kind of SVG, and so this is the background image base 64 encoded, but somewhere down there, I need to scroll a lot, you will see these paths. And unfortunately, Senses or the map chart doesn't support paths, so I need to transform them to polygons. And I found this tool that is working quite okay, and I put the URL here, and hopefully I can click it, or I can copy it out. So, and it works like that I can simply upload my file. So I have my Vienna map with the paths, and it transforms it. So you see the title. It transforms paths to polygons. And now you see what I'm receiving. So I see these are the polygons, and what you see that I'm losing some kind of detail. So you see it here in the edge of the bus, for example. The path has a quite good quality. The polygon quality is quite okay. So if I want to have it pixel perfect, I need to invest time to resolve it, to find a way to make it work better. You see, for other shapes, it works pretty good here for the church. I don't see many errors here in that transformation. And now I haven't found a nice way to download it, so I can't press. Unfortunately, I can't press here and save it, because it only gives me the PNG back. So my approach was, I'm sorry for that, not that. Was to use like the inspector and go to the SVG and copy it out of it, and copy just with Control C. I can copy the SVG, paste it to a text editor, and store it. And now we see here the difference, that we don't have the paths anymore, we have the polygons. And what we see here is the polygon description, and it's a little bit different. So it's not the GeoJSON standard here, but you see like the X coordinate and the Y coordinate as pairs. And you see this, and the coordinates are separated through a space. And now I can, typically I can remove the image, but that's not really required. Now I can go to ClickSense, and as Qlik supports XML data, I will create a new app. I can upload this XML into ClickSense. And what I have to do is I have to transform the polygon definition of SVG into the GeoJSON description. And I can quickly show that. Let me jump through the script. And so yeah, I didn't prepare a super duper presentation. That's why we need to go through all these folders, but it's not that complicated. So here we are. I can select all data and can here select my polygon. And now I see the structure of the SVG. It's with all the X paths here, and I can simply load all the polygon data. Now I have them here in a row. That's already pretty cool. So I can use maybe string replacements to get the square brackets and the commas that are required, and so on. I have published the code that I have built. So what I'm using, I'm splitting here this point with a subfield function, and this is standard Qlik. I don't think I need to explain standard Qlik. So actually my script, I can quickly show it here. What is the idea? With the subfield function, I can Qlik automatically generates me rows by splitting the long string with the space. So I can just show you some hidden features of the subfield function. What happened? Just to show you the result. So what you see is that I'm getting for every point a row in my data table. So I had round about, I think, 12 or maybe 20 polygons, but the subfield function without parameter. So if I let typically we are using subfield with a third parameter, but if you let it out, it will generate you additional rows in the table. And then I can use these go back here, this information to split the X coordinate, to split the Y coordinate, and to do some further transformation with it. So this is what I've done in ClickSense. So I just want to show you the major steps. The second step that is required, and I want to come back to that slide, is the polygon description and SVG ends here. So it's not required in SVG to have the first point and the end point the same. So I need to add like the first point here in to the polygon description. That's why I have plotted the first point for every shape and add it to my data table, and that's it. And then I have the data in ClickSense. And let me just jump to an empty sheet and show you what is required in the UI to generate that app. So first, I need my map object. Then I need to get rid of all these background layers. So I'm clicking here on white space. And what is also important, I don't want to work with VGS 84 coordinates. I want to work with pixels, and so I'm setting here to the projection to meter. And now I can go into the layer and generate my first layer. So I'm selecting this. Let me find it. So this is my map, and I have transformed my geodata here in the right, hopefully in the right way. So I select my points, and then I see immediately the polygons that I have generated in Inkscape. You see, sometimes I have also marked the garden. So this is something that I didn't clean up. Okay, now I have already my polygons and it's already interactive. I can click on it. Yeah, but somehow I'm missing the background image. So this is the next step. I need to add a background layer, and this is done here in the add layer. And now I need to choose the right format, and I need to add the image. And this is done by URL. So, and now there are different approaches. So how to get an URL here. And the easiest way is to upload the file somewhere on an external, on a public server. So you go on a server at the customer that can be reached by HTTP. What is also possible is to upload the image to the ClickSense content library and generate the URL. And I will copy paste it. So this is a generic way to load an image out of the app content library. And then I can go here, copy the URL. So, and I'm still not seeing anything. So I need to put the image at the right place. And therefore, for that, I can use these coordinates. And the image is placed within these coordinates that I need to define. So I need to define the upper left edge and the lower right edge of the image, so that it really appears behind my shapes that I've set on the that I've added so far. So what I typically do is I'm going here into Windows Back and see what dimensions my image has, and I'm always need to guess where to add them, and I also need to remember them. So now we will see if it will work. That's the most critical point. We see it already appearing, and that was my my upper left point, and my lower was okay. I can't remember. 976. And that's it. So now I have a perfect overlay of my shapes and my image. And of course, it's not really nice that we can't see our buildings in the background. So I can go in and change it a little bit, and maybe give the background another color, so that Okay, now I can see it, so that the user maybe realizes what is clickable, and now I have already created that kind of visualizations, and that cost me some effort to find a way that my shapes and my image really overlay. I plan to write some kind of document that supports you, but at the moment, yeah, you will see if you play around with it that it's not that easy to get them really 100% overlapping. But there is a logic behind that, and when you understand that logic, it should work every time. Okay, and this is how you can, like, the idea here is to use, for example, warehouse images or factory images, manufacturing lines, and you can really then click on every machine and get the get the data for this machine here on the right. Have a really nice selection image that every user can understand, rather than a simple filter box.
Great. Thank you for showing that to us.
It is required to be open. It is required to use different tools, and you need to transform it from paths to polygons. But at the end, you have, from my view, you have a really cool result.
Yeah, I
Any questions for that example? And of course, you have like tooltips and all the stuff that is included here. You can add images to the tooltip, and hopefully, some soon some visualization. So you can, if you imagine you have your production line, you can simply click on click on an image, and you will see even a measure or a visualization, a trend for errors for that line. So we have some also cool features for the map on the roadmap. And actually, just to close that or understand that, give you some background, how, for example, the body map was generated. And I think in this, my colleague, this was done by Patrick, the product manager. He used another tool, but actually, I think he had the same approach. He started with an image and used some kind of painting tool to mark that areas, and then uploaded everything into ClickSense. So not every time you need the background layer. It gives you more details. It gives you some colors and so on. But sometimes the shapes are enough to upload to Qlik. In our case, I think it doesn't really make sense without the background image. I can go back. So without the background, you can't really recognize anything. It's hard, at least. But for those who know Vienna well, maybe that's already enough.
Yeah, great. I think the critical part, as you mentioned, is the path to polygons.
Yeah.
If that could be facilitated in some way, I think we could use a great audience with that. But otherwise, it remains very technical.
Yeah, that's the challenge. So that's the biggest challenge.
Yeah.
But it's possible.
Yeah, but
so I understood it, how it works.
no, I think everybody would understand it after seeing this session or looking at your page. But like making it up from scratch, it's quite some effort, I assume.
Yeah.
Yeah. Well, thank you from my side. I really enjoy seeing these functionalities. I hope I can use them in practice soon. Anybody else? Do you have some questions before we round up the session? If not, then thanks again from my side. Please be so kind and let me have the slides and the link to your GitHub page, of course, so I can pass it to the audience after the meeting. So for me, it was very exciting. I hope for the others as well. And yeah, maybe we can have you back some point in the future when there are new developments regarding the map object or the map chart. So I really liked it. Thank you very much, Michael.
Thank you to have the possibility to show that. Have a nice evening. Bye.
Thank you and bye.